tutorial is on using the remainder theorem and using division to factor polynomials completely. Let's take a look at what this means. First, the remainder theorem. The remainder theorem states that if we have a polynomial and we want to make the input of the polynomial some number a, then the remainder of the polynomial is the actual value of the polynomial at that given input. In other words, if I have a polynomial p of x and I want to divide it by x minus a, the remainder is the value of my polynomial when x equals a. Or I can use synthetic division, and when I get the remainder, that is the value of my polynomial. We'll take a look at an example of that in just a moment. The other thing that we want to really talk about is using division to factor polynomials completely. What that means is that if we have a polynomial and we're given a linear factor, or we're able to determine a linear factor, we can use that with division to factor out the polynomial, making it smaller each step or easier to factor each step until we can do factoring by grouping or using the quadratic formula. So we're going to take a look at that as well. Let's start with the remainder theorem. I have a polynomial p of x that is equal to x cubed plus 4x squared minus 8x minus 6. And I want to know what the value of this polynomial is when x equals negative 2. In other words, I could rewrite this and put negative 2 into my polynomial each place that there is an x and simplify it. Or I can use synthetic division to find my solution. We're going right now to use synthetic division. First thing we're going to do is take our negative 2 and put it on the outside of our synthetic division symbol. And we're going to use the coefficients of our polynomial inside. So the coefficient of x cubed is 1. The coefficient of x squared is 4. The coefficient of x is negative 8. And our constant is negative 6. Remember that with synthetic division, we're going to drop the leading coefficient, multiply it by the divisor. 1 times negative 2 is negative 2. Add it to that coefficient. 4 plus negative 2 is 2. And repeat. Multiply by the divisor. Add to the coefficient. And repeat. Multiply by the divisor. Negative 12 times negative 2 is a positive 24. And 24 plus negative 6 is 18. Since there's nothing left to do, 18 is my remainder. According to the remainder theorem then, the value of my polynomial when x is negative 2 is 18. And I can check my work. Remember I said all we needed to do was to replace the x's in the polynomial with negative 2. So when we check our work, we get negative 2 cubed plus 4 times negative 2 squared minus 8 times negative 2 minus 6. This would be p at negative 2. And so we need to simplify this. Negative 2 times negative 2 times negative 2, which is negative 2 cubed, is negative 8. And then the next step is to take my negative 2 and square it. So negative 2 times negative 2 is a positive 4. And 4 times 4 is 16. And then we simplify the next term. Negative 8 times negative 2 is a positive 16. And our constant is negative 6. Next thing we need to do is simplify the next step. Negative 8 plus 16 is 8. Plus 16 minus 6. 8 plus 16 is 24. Minus 6 is 18. So you can see we have the same thing. Because the remainder is not 0, that means that negative 2 is not 0. So it is not a factor of the function. X plus 2 is not a factor of x cubed plus 4x squared minus 6x minus 6. However, if I replace negative 2 in my polynomial in place of x, I would get 18 for my solution. So if my input is negative 2, my solution is 18. That's what the remainder theorem tells us. Go back and rewatch this if you're still a little bit confused. We'll do more practice problems in class. Let's look at one final example using division to help us completely factor a polynomial. I want to completely factor the polynomial y equals x cubed minus 4x squared minus 9x plus 36. And I'm lucky because I've been given a factor, x plus 3. What that means is that I know x plus 3 is a factor. So if I use synthetic division or even long division, I know that I'm going to have a remainder of 0. If I don't, then I've done something wrong, or somebody's lied in telling me that x plus 3 is a factor. Let's use synthetic division since it's the easiest way to do it. So we start by using the opposite of 3, or negative 3. And then our synthetic division symbol. Then we bring down the coefficients of our polynomial. X cubed has a coefficient of 1. X squared has a coefficient of negative 4x squared has a coefficient of negative 4. Negative 9x, the coefficient is negative 9. And then our constant, 36. Using synthetic division, we bring down the leading coefficient. We multiply by the divisor. 1 times negative 3 is negative 3. We add to the next coefficient. Negative 3 plus negative 4 is negative 7. We multiply by the divisor. Negative 7 times negative 3 is a positive 21. We add that to negative 9 and get a positive 12. And we multiply by negative 3 and get negative 36, which we add to a positive 36 and get a remainder of 0. So far what we know then is that we have factors x plus 3 and x squared minus 7x plus 12. These are our factors of our polynomial x cubed minus 4x squared minus 9x plus 36. But we're not quite sure that this is factored completely. After all, I have one linear factor, but I have one quadratic factor. Since I'm not looking for the solutions, I can't use the quadratic formula to simplify this. So what I do need to do then is see if I can factor further. I'm going to keep my factor x plus 3. That's already factored completely. Then I look at my x squared minus 7x plus 12, and I ask myself, are there factors of positive 12 that when I add them together, I get negative 7? Did you get x minus 3 and x minus 4? In other words, negative 3 times negative 4 is a positive 12. And negative 3 plus negative 4 is negative 7. Now, I have all of my factors for my polynomial. Y. Y equals x cubed minus 4x squared minus 9x plus 36. Or y equals the factors x plus 3 times x minus 3 times x minus 4. Now I can check my work here very easily. If I notice that my first two factors here are conjugate pair, x plus 3 and x minus 3. That means that when I multiply them together, I get the difference of two squares. So I'm going to multiply these, and I get y equals x squared minus 9. And I want to multiply that times x minus 4. When I do this, I can do that FOIL method that you like to use so often. And what I'm going to do, really, is multiply each term in the first binomial times each term in the second binomial. So x squared times x is x cubed. And x squared times negative 4 is negative 4x squared. And negative 9 times x is negative 9x. And negative 9 times negative 4 is a positive 36. And if you notice, we are back to where we started. So we know we factored completely because we had 3 linear factors. And we know that we factored it correctly because when we multiplied it back out, we got the same answer. Again, take the time to look at this.